Okay, so there's the bell. Class is now started, so you heard the bell. Take out your homework, put on your desk. Just a reminder, know your role. Facilitators, you are to encourage everyone to participate. Narrators, read the directions, please. Skeptics, double check each other's work to make sure that it matches. If anyone has discrepancies or different approaches, that's your job to point out. And materials managers, make sure that your table is complete, everything's in the right place. Okay, 7 minutes, and get to work, please. Pause the video if you weren't sure. Okay, now, so we are working on 2.2 today. Sum of any polygons, angle sum of any polygon. Before we did regular polygons, so we are going to do any polygon now. That includes irregular polygons. So any polygon that is not regular is irregular. So we're going to do the same concept, but with any other random size shape. Okay. So angle sum of any polygon. So it says focus question, 2.2 angle sum of any polygon. Focus question, what is the angle sum of any polygon with n sides? In your last class we covered n number of sides, and that is determined by the shape that you choose. If you have a triangle, that's 3 sides. If you have a square, that's 4 sides. Any 5-sided figure, the n will be 5. And how can you prove it? Okay. Now I put the answer to the focus question here, and it's actually almost like instructions. We can prove that any sum of any angles in any polygon by tearing off the corners and placing them next to each other to count the rotation angles. No, that sounds bad. So we can prove the sum, let's fix this, the sum of angles in any polygon. That's better. Okay. Now, when we're tearing off angles of a polygon, I'm gonna let a video play from YouTube, and that way you know what I'm talking about, or record a video from YouTube. So this is a video from YouTube. It's called The Adventures of Mr. Triangle, sum of interior angles of a triangle. It's kind of entertaining. I loved it. So here we go.
Of Mr. Triangle. Why, hello there. My name is Mr. Triangle, and here's my friend,
Mrs. Trapezoid. Hi, everybody. My friend is
Mr. Rectangle. Why, hello there. My name is Mr. Rectangle. My angles on the inside equal 360 degrees. What about yours, Mrs. Trapezoid?
Well, my angles equal 360 degrees. By golly, what are yours, Mr. Triangle?
Well, my angles equal, well, I don't know what my angles equal. Bloop, 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 bloop. No! What am I gonna do? Let's figure it out, huh? Yeah?
You got a friend in me. You got trouble, and I got them too. There isn't anything but what we do for you. We stick together, see it through, 'cause you.
Wowza! We learned that your angles are a straight line, which makes 180 degrees.
Oh my gosh, that happens every single time with a triangle. I can't believe it. What do you think, Mr. Triangle?
Well, it kind of hurt. Well, I'll be okay, but it's awesome to know my angles always add up to 180 degrees. Man, it just made my school year. I can't believe it. I'm just off.
Okay, so that was The Adventures of Mr. Triangle. And what they did is they tore off the corners of the triangle, and they made a straight line. So if you turn your book, I believe, let me double check the page number, to page 45, you'll see this. This is the same thing that Mr. Triangle went through. They tore off the edges and they lined them all up, and they ended up with a straight line. So the angle sum of a triangle, any triangle, is 180 degrees. Now, in yesterday's lesson, in the last class, we learned that this is true for regular triangles, equilateral triangles, triangles with the same angles, all 3 angles, and same side lengths for all 3. And now our triangle is what this looks scaling, and this is a quadrilateral with no properties that are specific, no congruent sides or parallel sides or anything like that. But they tore them off and they lined them up and they still got 360. Okay, so what is the angle sum of any polygon with n sides? How can you prove it? We can prove the sum of angles in any polygon by tearing off corners, our angles, and placing them next to each other to count the rotation angles. Okay, so that's what Devin did here, Devin being the student in this book. Okay, it says what angle sum does Devin's work suggest for the triangle, for the quadrilateral? Okay, and like we saw with Mr. Triangle, Devin's work is showing us that we have a 180 degree line here. So this is 180 degrees. Okay. And for the quadrilateral, we can basically make the same idea, and we can say that a quadrilateral has, I can start anywhere and I can draw all the way around 360 degrees. So what does the angle sum suggest for the triangle? 180 degrees, and for the quadrilateral we can say 360 degrees. Now it says test Devin's idea with a triangle, with triangles and quadrilaterals of your own design. Okay, so for number 2, you should draw your own triangle. So draw your own triangle and quadrilateral. Okay, draw your own triangle and quadrilateral. Don't write this down. Actually do this. Okay, and I don't want you tearing them off. Okay, we don't. I don't want to make a mess in the room. So instead of tearing off the corners, after you draw your quadrilateral, just measure the corners and add them up. I'll show you what mine looks like in just a few minutes. Okay. Number 3 says the same thing. Draw irregular pentagons and hexagons. Use Devin's method to determine the angle sum. Same thing. Draw your own and then measure. Okay. I don't want you cutting them out and tearing them out. It's too messy today. Number 4 says, does the draw and tear method, in our case it's draw and measure method, experimentation show the same angle sum pattern that you discovered with regular polygons? So does this pattern hold true to what we learned in your last class? Do the triangle measures, are they the same as the regular triangles, and quadrilaterals are the same as the square, and the pentagon and the hexagon same as the last time in the table that we made? Okay, I'll show you what my notes look like as soon as I'm done with the video presentation. Okay, so this is your homework, but I'll go back to that. You're supposed to also answer question B and C. Okay, now question B says, Trevor examined Devin's results from his study of irregular triangles. This gave him an idea to study polygons with more sides. He divided some polygons into smaller triangles by drawing diagonals from one vertex. This is page 46, I believe, right after 45. Okay. Number 1, it says describe the relationship between the number of sides of a polygon and the number of triangles formed. Okay. So question 1, 2, and 3. Sorry about that. Phone call. But I'm back. So questions 1, 2, and 3 about what Trevor examined about Devin's method. So answer these in your book along with question C. Now, question C is asking you to compare Trevor's method and Casey's method. So does Casey's method work? Yes or no? So what you're going to have to do is look at the difference between the two and see which one works and which one doesn't. Okay? So questions A, B, and C should be in your book. Okay? I'll try to make a copy of your notes so you guys can see what it looks like. Here is your homework for tonight. Page 53, 3 through 11, and page 57, number 19. The optional recommended is Interact Math. it should also be on that packet paper that you received when you left class the last time. Okay.